Hello, cosmic explorers, and welcome back to Extraterrestrial Mystery, your portal to the deepest enigmas of the universe. Today, we're diving into the most mind-bending, spine-chilling journey yet. What happens if you fall into a black hole? Imagine standing at the edge of a cosmic abyss, where time warps, light bends, and reality itself unravels. At the photon sphere, you'd see 100 versions of yourself staring back. In just seconds, even light can't escape. This isn't sci-fi, it's hard physics, straight from Einstein's equations. Buckle up, because we're about to plunge into the heart of a black hole and uncover the secrets of the cosmic abyss. What happens when you fall in? Picture this. You're floating in space, staring at a void so dark it swallows everything. Light, matter, even hope. This is a black hole, a place where the universe plays by rules so strange they'd make your head spin. We're not talking about a sci-fi fantasy here, but a real phenomenon that even baffled Einstein himself. He called it God dividing by zero, a place so impossible he didn't believe it could exist. Yet, humanity proved him wrong, capturing images of these cosmic monsters, like Sagittarius A at the heart of our Milky Way. Today, we're not just observing from afar, we're sending you on a one-way trip into a black hole. What will you see? What will you feel? And will you survive? Let's find out. First, let's unpack what a black hole is. Imagine a massive star, millions of times heavier than our sun, reaching the end of its life. When its fuel runs out, it collapses under its own gravity, shrinking into a point of infinite density, a singularity. This isn't just a tiny. It's a tear in the fabric of space-time, bending reality so fiercely that nothing, not even light, can escape. Einstein's theory of general relativity tells us gravity isn't just a force, it's the curvature of space-time caused by mass. A black hole is like a deep well with vertical walls, warping everything around it. No wonder Einstein thought it was too wild to be real. In 1939, Einstein published a paper insisting stars couldn't collapse into such points. But that same year, Robert Oppenheimer, yes, that Oppenheimer, and physicist George Snyder proved him wrong. They showed that massive stars could collapse into black holes, creating singularities with infinite gravity. And here's the kicker. Anything can become a black hole if squeezed small enough. Compress the sun to a 3-kilometer ball, and it's a black hole. Shrink Earth to the size of a marble 9 millimeters, and it's gone. You'd need to be smaller than a proton. That's the Schwarzschild radius, the point of no return where gravity takes over completely. Now let's choose our black hole. We could pick a small one, but where's the fun in that? Let's go big. Sagittarius A, the supermassive black hole at the Milky Way center, with the mass of 4 million suns. It's one of only 2 black holes humanity has photographed, and it's practically our cosmic neighbor. Imagine we're in a spaceship, parked 100 million meters from its event horizon, the point where escape becomes impossible. I'll stay safe in the ship, observing while you take the plunge. Don't worry, we've got a special watch to track time from your perspective and mine, because things are about to get weird. As you begin your free fall, the black hole looms ahead, a dark shadow surrounded by a glowing accretion disk. Matter spirals in, heated to millions of degrees by friction, blazing blue or white in reality, though simulations often paint it orange for clarity. It's a spectacle so complex it'd take a laptop over a decade to render. You check your watch 30 minutes into your journey. You've covered just 0.1% of the distance. My watch, back on the ship, shows I'm only 11 seconds ahead. Not too bad, right? But general relativity warns us. Near a black hole, time plays tricks. As you drift closer, space-time warps around you, creating bizarre visual effects. Light from behind the black hole bends, letting you see its far side, like peering around a cosmic corner. The gravitational lensing effect makes the black hole's shadow grow faster than expected, as light that would have passed you curves into your eyes. 2 hours in, you've covered 1.4% of the distance, but my watch now leads yours by 44 seconds. The time gap is growing, and it's only the beginning. After 12 hours, you check your watch again, and it hits you like a cosmic punch. I've been watching you for nearly 15.5 hours. Time is slipping away faster for me than for you. You're nearing a strange, magical place. the photon sphere, one of the universe's weirdest realms. Here, gravity is so perfectly balanced that light itself can orbit the black hole. Not reflected light, but photons trapped in circular paths, like cosmic dancers. If you could freeze time here and look around, you'd see something jaw-dropping. Multiple copies of yourself, your own back staring into space, mirrored endlessly. It's not magic. It's space-time bending light into loops, creating a gallery of views. No tech needed, just the raw power of gravity. You push past the photon sphere, and the black hole's shadow looms larger, swallowing your field of view. It feels like darkness is closing in, warping the stars behind it. After 13 hours, you're just 24 minutes from the event horizon. My watch says I've been watching for 20 hours. Time is stretching like cosmic taffy. 18 minutes later, my watch jumps to 40 hours, while yours barely moves. The gap is staggering. Your 18 minutes feel like 18 hours to me. And then the final moment approaches. In just 6 minutes, you'll cross the event horizon, the point of no return. You close your eyes, take a deep breath, and check your watch one last time. It's glitching, or so it seems. It says I've been watching you for an infinite amount of time. But it's not broken. It's physics at its wildest. From my spaceship, decades pass as I watch you creep toward the event horizon. You turn red, then fade, as your light shifts to infrared due to gravitational redshift. I'd need special telescopes to see you now, and I'll never see you cross the horizon, not even if I lived forever. Your final 6 minutes stretch into eternity for me, a quirk of Einstein's equations. But what do you experience? Strangely, you might not notice crossing the event horizon. You can still see the universe, distant stars, my spaceship floating far away. But everything, including you, is hurtling toward the singularity. Inside the event horizon, spacetime collapses into a point of infinite density, where physics as we know it breaks down. Time stops. To escape, you'd need to move faster than light, impossible. As you near the singularity, tidal forces stretch you like spaghetti, a process called spaghettification. Your feet pull ahead, your body elongates, and you merge with the black hole, becoming one with its eternal mystery. There's a myth that you'd see the universe's entire future unfold as you fall. But that's not true. Aberration, a distortion of light, compresses the cosmos into a tiny, shrinking ring as you approach the singularity. The universe doesn't flash before your eyes. It squeezes into a pinpoint, then vanishes. It's a chilling end, but also strangely beautiful, like dissolving into the fabric of the cosmos. Let's step back and reflect. Black holes are more than cosmic monsters. They're windows into the universe's deepest truths. They challenge our understanding, from Einstein's skepticism to Oppenheimer's bold predictions. They show us how fragile our reality is, yet how breathtakingly strange it can be. Imagine the scientists who captured Sagittarius A's image, staring into the abyss and finding proof of what was once thought impossible. That's the power of human curiosity, pushing us to explore the unknown, even when it terrifies us. So, what do you think? Would you dare take a trip to a black hole's edge, knowing you might see yourself mirrored in the photon sphere? What does the idea of spaghettification make you feel? Fear, awe, or both? If you could send a message to the singularity, what would it be? Drop your thoughts in the comments, and don't forget to like, subscribe, and hit that bell to join our next cosmic adventure on Extraterrestrial Mystery. Thank you for plunging into the abyss with me on this 20-minute journey. See you in the next video, where we'll unravel more secrets of the universe. Remember, in the shadow of a black hole, every moment bends the rules of reality. Until next time, keep looking up,